All right, section 1.1, set statements and reasoning. We're going to record several videos for this. So the first one, let's look at sets and statements, and then we'll go on to reasoning for the second part. So let's jump right in. So a lot of this is just information that you could just take on yourself. I thought like putting a little bit of voice onto it, and then like also just kind of like, at times I think there will be a benefit of an explanation that may be valuable. So a set is a collection of objects, all of which are known as the elements of a set. So for example, if we have a set that we're going to call A, sorry about that. We have a set we're going to call A, let's say, right here. And so then that set can be defined as these elements. So 1, 2, and 3 are elements of that set. So the set can be read as A is the set of elements 1, 2, and 3. In geometry, geometric figures such as lines and angles are actually sets of points. So we'll kind of get to that as we move through this. Where A is 1, 2, 3, the set, and B are the counting numbers. Remember, counting numbers got our 1, sorry about that, 2, 3, 4, and then dot, dot, dot all the way to infinity. So that's what counting numbers would be. A is a subset. So there's a new word that we're going to put in there, and that's subset. So a subset means it's a smaller set of a larger set. So A is a smaller version of B. All right, classifying each of the following as a true statement or as a false statement. So we're looking at statements now. And so we've gone from sets to statements. Let me see if I skipped a slide here. It seems weird. Yeah, we did. Sorry about that. So a statement. A statement is a set of words and or symbols that collectively make a claim that can be classified as true or false. So what we're looking at here is that are these statements true or are they false? Not are they a statement or not a statement? Are they true statements or are they false statements? Some statements can contain one or more variables. A variable is a letter that represents a number. So looking at these as true or false. So they're all statements. So 4 plus 3 equals 7. That's a true statement. Perfect. The angle has two sides. So we have the angle here, so made up, and it has one side, two sides. So that's a true statement. Robert E. Lee played shortstop for the Yankees. Well, that's definitely a statement, but it's not true. Robert E. Lee, the general that we know from history, was not a shortstop for the Yankees. So that's a false statement. I'm going to go on to the next slide to kind of put these in. And then the next couple is, all right, there we go. All right. 7 is less than 3. And that we know that it's a false statement because 7 is clearly greater than 3. And look out. So here's an example of something that's not even a statement. That is just an exclamation. So look out, not even a statement in a sense. All right, let's see. I feel like I skipped slides again here. Got a little lag or something on my computer. No. Oh, these are just additional ones. The claim x plus 5 is equal to 6 is called an open sentence or an open statement. And the reason is we can't really classify it as true or false. It all depends on what x is. So if I came along and they said, for example, if I said let x be equal to 1, then we would say that would be a true statement because 1 plus 5 would be equal to 6. If x was not equal to 1, then that would be a false statement. So we call that an open sentence or an open statement. These are things you want to add to your notes and to let me pause for a second. Sorry, I wanted to use the right vocabulary, to your formula sheet that you can use as extra credit and use on your test. All right, some statements containing variables are classified as true because they are true for all replacements. So like for example, the commutative property of addition is usually stated as a plus b equals b plus a. So no matter what numbers we plug in for a and b, that's always going to be a true statement. A negation. A negation of a statement, and this is a great one to add down, this is something that comes up in a lot of different areas. A negation of a statement makes a claim that's opposite of the original statement. So for example, if the given statement is true, then the negation is false, or vice versa. If the given statement is false and we negate it, we're making the statement true. So if P is a statement, then this is the little symbol that we use for negation. It means not. It's read as not P. So make sure you put that in your notes also. Compound statements. So a compound statement is formed by combining other statements using building blocks. And so we're going to take two statements and put them together. So in such cases, we may use letters such as P and Q to represent the simple statements and then put them together into a compound statement. So like for example, if we have P is the statement 4 plus 3 equals 7, and we have Q, which is a statement that Babe Ruth was a first US president, then we put those two things together, we end up getting a conjunction that says the statement 4 plus 3 equals 7 and Babe Ruth was a US president. So a conjunction, the main thing I think that really take away from a conjunction is going to use the word and. That's terrible handwriting, I'm sorry about that. So a conjunction is going to be using the word and it's going to use this symbol. So like for example, if I did P and Q, so you know there's your and, so this would be P and Q. And that's how we'd write that conjunction. A disjunction, on the other hand, would be an or statement. So in a disjunction, we can see the or right there. So a disjunction of this would be, instead of P and Q, it would be P or Q. All right, so it's one or the other. And that's all we need to cover about that right now. More comes up with that later. That's just like a foundational piece. So a conjunction is true under these following conditions. And these are kind of getting like what we call a truth table. And so in a truth table, what we see is that a conjunction is only true when P and Q are true. So when we come down here and we take a look at this, what we see is that when P is true and Q is true, then P and Q is true. But if one of them is false, see here how Q is false, then we automatically know that because you have to have both of them in a conjunction, both of them have to be true. Then we get to the spot where one of them is false, so therefore the whole entire conjunction is false. So the whole conditional statement is false. As you can see that throughout the table. Whereas in a disjunction, because it's an or statement, we have different scenarios, because as long as one of them is true, then our overall statement can be true. So a true or a true gives us a true or a false gives us a true, or a false or a true gives us a true. But of course, if we have both of them false, that automatically guarantees a false statement also. So that's a disjunction. All right, or inside the truth table, excuse me. All right, now we move on to conditional statements. So all of these things along the way, like I think like the main thing is kind of going through and just identifying the basic vocabulary. So anything I'm stopping and kind of like pinpointing on or talking about, that's kind of the main thing. There's no need to write all of this down. This is why I highly recommend like printing these out, and so that way you can just like highlight and write on top of them if you have the means for that, or maybe watching the video and writing things down, hitting pause is going to be valuable for you. So in a conditional statement, what happens is that we had a conjunction, which is P and Q. We have a disjunction, which is a P or Q. So now we're on to a conditional statement. And in a conditional statement, it's if P, then Q. It's like an implication saying like, if this happens, then this will happen. And this can be classified also as true or false. So a statement of this form can be written in equivalent forms. For instance, the conditional statement, if an angle is a right angle, then it measures 90 degrees. That's clearly a true statement, right? And we can write them in other ways, and that's equivalent to saying all right angles measure 90 degrees. But for the ease of conversation right now, let's just focus on a conditional statement is going to be an if-then statement. So here's a couple examples. In the conditional statement, if P then Q, we call P the hypothesis. So when we look at like whether it be statistical analysis or whatever it is we want to form hypothesis, whether it be scientific method, whatever we're going to use this for. So it's like saying if we have our hypothesis, then we can guarantee this conclusion. All right, so two sides of a triangle are equal in length. The conclusion, the two angles of the triangle are equal in measure. That's an isosceles triangle if you're wondering. All right, so for the statement, if P then Q, the hypothetical situation describes P implies the conclusion of Q. This type of statement is often used in reasoning. which is what we're going to cover later in this section. So we're going to look at reasoning. So we're like kind of reasoning our way through. All right. Success in the study of geometry requires vocabulary development, attention to detail, and order supporting claims and thinking. Reasoning is a process based on, actually, I'm going to stop right here. I'm going to do reasoning in the next video. All right. So just going to go back to their slide and I'll clean this up here in just a minute. So we're going to stop with this introduction. I'll pick back up. Thanks.